Hey guys, Mr. King here. Today we are going to be talking about ways the Earth moves and how we rotate on our axis and kind of spin in a circle, and then also how we rotate around the sun. And these types of movement give us not only night and day, but it also gives us our different seasons of the year. And a lot of people believe that we have different seasons of the year because we get closer to the sun or we get farther away from the sun. So in the summertime we must be really close because it's hot, and in the wintertime we must be farther away because it's cold. But that is not true. That's a misconception a lot of people have. So we're going to figure out why we have those different seasons and why we have brightness and darkness for night and day. So first off, the question is, who is moving? The Earth is the one that is moving, even though it appears that the sun does. And I use the example as watching a sunset as a great way of showing you guys how it looks like the sun is moving. If you guys have ever gone down to the beach on Lake Michigan and watched the sunset, it appears as though the sun is dropping out of the sky. It goes closer and closer to the waterline, and then it looks like it disappears beneath the water almost. And it looks like the sun is the one moving, but in reality the sun is standing still. It's the Earth that is the one that's moving, and the Earth is spinning in place. It's spinning on its axis. So it gives us this illusion that the sun is the one that moves through the sky. If you watched it from the time the sun rose to the time the sun set, you would see the sun look like it's traveling all the way across the sky. But it's not really the sun that's traveling, it's really the Earth. So the Earth moves in two different ways. The first way is called a rotation. And rotation is the spinning of the Earth on its axis, and this takes 24 hours to complete one rotation. And as the Earth spins in place, that is what gives us night and day. Part of the time when we're spinning, we are facing the sun, and part of the time we are facing away from the sun. So that's what gives us our different time periods of the day with night and day. So watch this little video here, and this will show you kind of what happens. So you can see right here, you can see where the sun is coming and illuminating the Earth. Now we're going to get to where North America is going to come into the picture here. Right about now, New York gets bright, and then Michigan, and then Texas, and then California. And as you watch that amount of sun, that covers different areas, and that's where we get our time zones from. So as it rotates through, you can see it's spinning. If you go to the East Coast, like New York, they're going to have sunrise before us because they're going to see the sun first. It's going to come around, and the way the Earth rotates, you can see that if we go back to the spot where we are, which is right here. Right now, New York is starting to get that first bit of light in the morning, and they're having sunrise. Now over on the West Coast in California, it's still completely dark. They're 3 hours behind. So even though the sun is showing up at New York at 7 a.m., because we have time zones to account for the sun shining in different spots, in California, it's only 4 a.m., so obviously it's dark there. Now if I play this a little bit more, now you can see Michigan just started to get some light, and we see the sunrise coming up. And now it'd be like in Texas, and now in California. And as we travel around in this rotation on our axis, we start to lose contact with the sun. Now you can see Michigan is kind of going over to the other side now, and you can imagine right about now is where you lose the vision of the sun, and that's where you see your sunset. Okay? And then when you're in darkness is obviously nighttime. So we're just spinning in place, and we spin at a rate that it takes 24 hours to complete that rotation, which is why we have 24 hours in a day. So not only are we spinning in place on our axis, we're also spinning in a giant orbit it's called a revolution. Okay, so the Earth moves around the sun in a regular curved path. It's kind of like a circle almost like an egg shape, called an orbit. And it takes 1 year for the Earth to revolve all the way around the sun. So in the time it takes us to revolve all the way around the sun, imagine you're running around a track, we spin around 365 times on our axis because we have 365 days and nights. And so that amount of time hopefully puts in perspective a little bit. We spin around a lot of times in order to create one full revolution. So it takes a while to get around the sun. This is where we get our time frames from. Obviously, one day is 24 hours because that's how long it takes. And 1 year is 365 and a quarter days, where we have our leap year to account for that extra quarter day every 4 years. That accounts for the time it takes to travel all the way around the sun. Now, as we travel around the sun, we start to get seasons. And the seasons occur due to the Earth's tilted axis and its revolution around the sun. So watch our revolution around the sun here. And as you can see, we're tilted. We're on an angle of 23.5 degrees. And there's times where we're tilted toward the sun and times where we're not tilted toward the sun. Now, this is not completely accurate because as you see it making the revolution, it's only spinning around like 10 times. If this were a more accurate animation, this would have the Earth spinning around 365 times in the amount of time it takes to spin one time around the Earth, because there's 365 days in 1 year. Okay, so as you can see at different parts of this, you have different parts of your Earth are leaning towards it. Okay, like right now, we have part of the Earth that is pointing towards it is, you can see a little piece of Australia. Okay, so that's going to give Australia some warm temperatures. Now as we circle around, when we come over to this side, now you can see there's Europe and Asia and Africa. Their top parts are getting the sun where the bottom is not. Okay, and this all contributes to give us seasons. So what season is it? When the northern hemisphere, and our Earth is divided into two hemispheres. You got the top part is the northern hemisphere. So when the northern hemisphere is tilted toward the sun, like I was just showing you there, that is summertime in Michigan. When the northern hemisphere is tilted away from the sun, the season would be winter in Michigan. And that makes sense because when you're tilted in towards it, you're getting more rays of sunlight, and when you're tilted away from it, you don't get as much. So this will help you see it a little bit more and help you understand how the sun's rays hit the Earth and give us different seasons.
Not everybody knows what exactly causes the changes of the seasons. Some people think that it is wintertime when the Earth is farther away from the sun, which is why it's cold. However, the Earth's orbit is almost a perfect circle. The real reason is the Earth's axis. The Earth is tilted, and it is winter in the northern hemisphere when the northern hemisphere is tilted away from the sun, and it is summer when it is tilted toward the sun. In the winter, the sun rays are angled. In the summer, we are getting direct sunlight, which heats the Earth much better than angled sunlight. This is also why the northern hemisphere is always the opposite of the southern hemisphere. While we are angled away from the sun and facing the cold, harsh winter, Australia is sitting in the sunlight, enjoying the heat.
All right, so I can tell you guys about
While we are angled
this idea. If you look in the northern hemisphere, we're pointed away from it right now. So this is wintertime in Michigan. Now in the southern hemisphere, Australia is a country in the southern hemisphere, and I lived in Australia during the winter months in Michigan. I actually flew home the day before Christmas. I flew from Australia to Michigan. And when I left Australia, I spent the day on the beach. It was 100 degrees out. It was very, very hot. Spent the whole day on the beach playing football, running around, having fun. I get on a plane. I fly all the way back to Detroit, Michigan. And in Detroit, Michigan, there was 2 feet of snow on the ground. And the whole reason is because I was in the southern hemisphere, which was tilted toward the sun, and I flew to the northern hemisphere, which was tilted away from the sun. So they have opposite seasons based on what hemisphere you are in. Now, a lot of people think that the Earth is closest to the sun during the summer. That is wrong. The Earth is closest to the sun during the winter. Okay, we have this time called perihelion, and that is the closest we get to the sun out of our whole revolution. And then if you look on the other side, that aphelion happens in the summertime. That's when we're farthest away. And so it's actually the opposite of what most people would guess. You'd think, oh, it must be hot, we must be close. It's the opposite. It all has to do with the tilt. Okay, so we go back to the way our axis is tilted. When we are tilted toward the sun, it's summertime. When we're tilted away from the sun, it's wintertime. It does not matter how close you are. It's just about being tilted toward, and that way you get more direct sunlight. So you guys can check this out and see we go from being close in January, and then we rotate kind of through the season of spring, and then when we get to summertime, we are farther away than we were in January. So it doesn't have anything to do with how close you are. It's all about the tilt. It's all about where you get those sun's direct rays. All right, guys. I hope this all makes sense. We'll talk a little bit more about it in class. You guys have a wonderful night, and I will see you all tomorrow.